All right, 2-8. Two variable inequalities. Ooh, that sounds interesting. Let's see if, there's my glasses. Go on the yellow sheet. It says, I can solve two variable inequalities. Well, yeah, that's exactly what it says up there. We're going to graph those two variable inequalities. So you can rate yourself before the lesson on the yellow sheet. And if you did the 2-6 and 2-7 stuff already, if you watched all of those, you could rate yourself after the lesson and after the homework on those, and you would realize there's nothing more on the sheet. 2-8 is the last section. So we take 2 days on 2-8. A day, day and a half on review, because I don't think we're going to spend the whole day on the second day of 2-8. And then a test. You know, we're already at a test again. And so if you're thinking retake on that last test, boy, oh boy, I sure would do that stuff over in the break if I were you. Get that done right away before we start working on everything for this test. Here we go. A linear inequality. What's the root word of linear? Line. So these are lines, but they're inequalities, so not always equal to. It has that less than, greater than thing going on. Now, a two variable inequality whose graph is a region of the coordinate plane is always bounded by a line. Sometimes that line includes answers, sometimes it doesn't. So what we're seeing here in these graphics is, how are we supposed to know if the line has answers on it or not? This line is dashed. That means anything on that line is not an actual answer. It's just a border for the answers. This one is solid. If it's solid, those are actual answers. Just like I've been talking about in class, if you've been listening to the videos, dashed lines, dotted lines are helper lines. They're not our final answer. This is a final answer. So, they are called boundary lines. If they're solid, there are actually answers on that line. What we see here is called a shaded half plane. The answers to these are always infinite. There's an infinite amount of answers. So it's not like we could just give people a number because, you know, it's infinite. It would keep going forever. So what we have to do is we have to shade to show people, hey, you can use anything over here, not what's on this line, but anything over here, and it's an answer. It'll work. On this one, you can use everything down here, and you can use the answers on the line. Those are all good. So all of these are done graphically, because we have to show that infinite piece to our answers. And that infinite piece is called the half plane. Solutions to the linear inequality are represented by the shaded region and the line if it's solid. Are the points on the boundary line considered solutions? Yes and no. Dashed. Solid. If you've been listening, you can answer this for me. On a dashed line, are those answers included? No, not the dashed. Remember, that's just a helper. Solid lines, are those included as answers? Yeah. So there's the first part of it. I start thinking, well, if I'm going to have to do this, obviously I have to know how to graph a line. Oh, good news. We all know how to do that. But I'll have to know when it's supposed to be dashed versus solid. Well, they're going to tell us about that in a minute. And then I have to know where to shade. They're going to tell us about that too. But we'll be able to do this. So if we want to graph linear inequalities, first thing, find that boundary line. Graph the boundary line. Get it on there. Find out where your answers start or stop. Bill, pay attention, please. If it's in slope-intercept form, quick graph. Love it. Y equals mx plus b. Use the slope and the y-intercept. So start with b on the y-axis, and then use the slope. Rise over run. Get yourself a line. If it's in standard form, ax plus by equals c. Love that one too. Some method. Super of these will be fast ways of graphing. And that'll give us our x and y intercept, 2 points to determine the line. Now, then you have to pause. And this is hard because you're like, I know where the line's going to go. But you have to know, is it going to be dashed or is it going to be solid? Notice these two, no equals bars. If it's just less than or greater than, it has to be dashed. We can't include those answers. But if it has the equals bars, then we go solid. We want to include those answers. So, there's more stuff down here. Well, yeah, we haven't shaded yet. You know, this is huge, getting the boundary line on there. Big deal, huge. But we have to figure out which side we should shade on. And the safest way, also probably the easiest way, is to test a point to determine which side to shade. So we put a point into our inequality, and we want to know, does it work or not? And what we do is we actually put it into the inequality and see, is it true? If it's true, then that's where we need to shade. If it's not true, then we know to shade on the other side. Because it's one or the other. It's either shading one half of it or the other half. Always has to be. So the test point, don't pick one on the line. That's not where the shading goes. The shading goes on one side or the other of the line. And if we can, if 0, 0 is not on our line, oh, that's a nice easy one to test. So that's a good point to test. Plug it into the inequality. If it makes the statement true, shade that side, because that's where all the solutions are. If it doesn't, you can go to the other side. Now, I'm going to put a little, but I would, if this is on a test, you guys have had plenty of time to finish up your test. If this is on a test, I'm going to, especially if it doesn't work, I'm going to test a point on the other side just to be sure that it works on a test. On homework, yeah, you know, if it doesn't work on this side, then shade the other side. But on a test, I would be a little more careful than that. So now, here we are already. They're saying, you can do this. Go for it. What is the graph of each inequality? So the first thing I'm looking for is, okay, is this going to be the nice y equals mx plus b, or is this going to be the standard form ax plus by equals c? Oh, look at it. That looks just like slope-intercept form. So for a second, we forget that it says greater than, and we just pretend that it says equals. And that tells me that my m value, my slope is 3, so I'm going to think of that as 3 over 1. And my y-intercept, my b value, is negative 1. Now, remember, it's nice that they labeled it b because then you can think alphabetically. I need to do the b before I do the m. So my b was negative 1. That means it's going right here at 0, negative 1. And then I remember my slope was 3. So from that point, I count 3 up and write 1. And I'm going to do that a couple of times because I'm really lousy at drawing straight lines on the smartboard. There's too many shadows. But push your pause button. Find it. Pause somewhere. Time it. So we need to know. Should it be dashed or should it be solid? So we don't want to get carried away. It is dashed. It doesn't have an equals bar. And a lot of times people make that mistake. They boom, solid line all the way up there. Don't do that. Stop and think. So dashed line. Then I realize, okay, one more step. Gotta figure out where to shade. Well, 0, 0 doesn't appear to be right on my line. It's close, but it's not right on my line. And that's a super nice point to test. So I'm going to test 0, 0 and see if it works. How do I test it? I put 0 in for x and y. Well, 3 times 0 is 0, so this is going to say 0 is greater than negative 1. Think number line. Is 0 bigger than negative 1? It is. So that means, if I could, I would turn my pencil sideways and shade, but I've got to kind of do this number. I'm going to make a big deal out of that because that's the side where all the solutions are. Now, like I said, if this is a test, I might pick a point out here like 6, 0 or something and put that in and make sure it doesn't work. Because it's one or the other, it's never both. And if I have time, it's always a good idea to check. Well, that's not so bad, huh? Well, then let's try another one. But I want your help much more this time. Do you recognize the kind of inequality that is? What would be better to use? Yep, got another one of those. So what's the slope? B over 1. We always want that as a fraction. What's our b value? Well, this doesn't seem any different than the last one. -1 up 3 over 1. And we'll push our pause button. Wherever it is. Should this one be dashed or solid? Got an equals bar this time. Need it solid. Make sure you put the arrows on there. Remember, stuff that goes forever, we have to let people know that. Well, it does appear that I can again test 0, 0, because 0, 0 is not on my boundary line. All right, 3 times 0 is 0, so this is going to say 0 is less than or equal to -1. 0 less than or equal to -1? No. So that means I can't shade where 0, 0 is. I have to go to the other side to shade. That's over here. Again, if it's a test, I'm going to test something like, I don't know, -1/4, and make sure that doesn't work in this, just to be certain. Because like I said, you're going to have plenty of time. You're going to have lots of time with this test. It's only on 3 sections, 2, 6, 2, 7, and 2, 8. So double check, make sure everything's perfect before you hand it in. Oh, well, here's a couple more. Cool. What are you thinking when you see A? Y equals mx plus b. Good thinking. Find M and find B. What is M? -2 over 1. What's B? 1. They really like the 1, don't they? 1 and -1 a lot. So where should I start with this graph? I'm going to go to the roll here. Move that up. So lose the equation. +1. Sorry, there was a slight pause there. Then down to and the right one. And I'm going to do that a lot. And I'll use the backward slope to get some numbers up here. Pause button. Solid. Dashed. Solid. Solid. Now my line's not straight, but I don't think that went through 0, 0, right? Well, then let's check it out. Well, -2 times 0, that's 0. And that says 0 is greater than or equal to 1. Not last time I checked. No. So that means I can't shade over here, because this is where 0, 0 was, and it didn't work. So the answers have to be over here. We can draw a line. We can do this. It's logic after that. Take a look at B. You like that one? What kind of form is that one in? Same thing. In fact, they did it again, didn't they? There's that negative 2 and that 1 again. Pause button. Dash your solid. Dash. There's no equals bar. That is less than. Mine's kind of looking dotted, but dashed or dotted is fine. Now, it's the same line we had before, so we know 0, 0 isn't on it, even though my line's not completely straight, so it might look like it is. And you know what? If you can't use 0, 0, big deal. Use like 1, 1 or 3, 0 or something like that. You know, use something easy that you can put in there. 0 is less than negative 2 times 0. For some reason I put a little dot there. Plus 1. 0 is less than 1. That is true. You shade this way. Like so. So far, so good? Piece of cake? Yeah. So now, why did they give us the same slope and the same b value for those? Because they want us to look at this. When the inequality is solved for y, how can you tell which half plane to shade? Oh, so they're saying, since all of these were slope-intercept form, we might be able to locate a shortcut for this shading. Let's see. So this one said greater than, and we shaded here. That one said less than, so we shaded here. This one said greater than, so we shaded here. And this one said less than, so we shaded here. I think we're supposed to notice something about those heres. Did you notice, Amos? What's going on? Yes and no. See, this one was greater than. It went to the right for that one. Yes. I'll give you 2 clue words, above and below. Look at the shading and think of the clue words above and below. For greater than, which way do we shade? Above the line. For less than, we shade below. Right. But again, that's not the best way to test. The best way to do this is to test a point. They are showing us a shortcut. That's what they're talking about here. Shortcuts are never a good idea. I mean, you know that. You always run into a situation where it doesn't work. But less than or equal to, shade below the line. Greater than or equal to, shade, or sorry, did I just do that reverse? No, I started to say it reverse, but I didn't. Shade above the line. So less than or equal to, we're shading below. Greater than or equal to, we're shading above. But much safer to just test a point, especially if you can test 0, 0. Much safer to do that. So now, we're going to see a real world situation here, which means a word problem. And we have to think about how all of this has been set up. So, this one says, you're going to go to the fair. Don't we all wish? Most of those things were canceled this year. You're going to the fair to go on the rides. You don't want to spend more than $15. Well, this book was written long ago, wasn't it? Tickets are a quarter? What fair are they going to? Tickets are a quarter. Small rides require 3 tickets. Large rides require 5 tickets. How many small or large rides can you ride? Okay. So I started thinking, there's 2 things I don't know, right? I don't know how many small rides I can go on. What else don't I know? How many large rides I can go on. But then I go back to my old fallback, which is, I'm going to find a total in here somewhere. And then I'm just going to reason to figure out how can I get that total. They gave us a total. What was it? $15. But was this about money? Okay, so then we have to figure out how many tickets we're going to get for $15. How can we figure out how many tickets we're going to have total for $15? How many tickets do you get for $1? Or, so 15 times 4 is 60. There's our total. Are they going to let you on the ride if you have 59 tickets? No. Will they let you on the ride if it works out so you have exactly 60 tickets? Yes, because you have them. So now I think, okay, so this is totally about tickets. That's what it's about. How many tickets did they say for small rides? 3. Plus, also want to go on to some of the large rides. I mean, who wants to miss the opportunity to get sick? Large rides, how many tickets? 5. Hey, that's not y equals mx plus b. That's okay. Thumb method. Standard form, we can do this pretty fast. We can see where they're at. So we find those 2 intercepts. Using the thumb method, we say, hey, if x is 0, they're not going on any small rides. 60 divided by 5 is? You're looking suspicious, so let me put that up there so you can see that it is in fact 60. Everybody okay with that? Okay, whether or not you have to use a calculator or not, I don't care, as long as you can find them. Now, you just go on the kiddie rides because you're like me, and at a certain age you started to puke when you went on big rides. So, 3 tickets each, 60 tickets. How many can you go on? Then do the division algebraically. 60 divided by 3. 20. Good news. We got a little 20 by 20 graph over there. Excellent. So this will be small rides. This will be large rides. And we can go by ones. So I just want to show people, I don't want to try and cram 1, 2, 3, 4, 5, 6, 7, 8 all the way across the thing. But I'll go every 5 and mark it. A name. What do you want to call it overall? Well, where are they going? The fair. We might as well call it the fair. People would be able to figure out what's going on if we did that. Now we had our 2 lovely little points, 0, 12. And 20, 0. And here's where it gets weird. Because you can't go up and say, I found half a ticket on the ground. Can I use this for the ride? But we are going to go ahead and do this normally and just graph it and say, hey, if I have exactly 60 tickets, I should be okay. So we'll make this solid. And I love this about word problems. Did we have an unlimited amount of money? So we know we can't shade out there in no man's land. We have to shade back here where we have enough money. So anything in that region, you have enough money for. You know, the goal is always to use everything in your last ticket. I always end up handing a couple off to a little kid in the crowd. 20 spares. There it is. So this one was in standard form. We had some that had our y equals mx plus b, our slope-intercept form, but we also got to see one that was in standard form. And I think we're going to skip the got it because it is it's too similar, really. All they did was change the money that you have to spend. Although you got more money, it was $30 now. You want more rides, so that's cool. And we will save absolute value inequalities for next week. So there you go. Yes, I know it looks long, but I wanted to be picky about which ones I had you do. I didn't want to say, let's do 9 through 61 all. That would be very bad. So I was picky. And yes, we are doing graphing, so squirt of antibacterial stuff, and that first wire bin up there, wire basket, has that -10 to 10 graph. I should look though and see if there's a word problem in this, because then you might want the one that just has graph boxes all over the whole thing. Oops. Kicking my desk. No, you'll be perfectly fine with the little -10 to 10s. There's no obnoxious word problem in it with big numbers or anything. So if you like graph paper, it makes it go faster sometimes, feel free. Give yourself a squirt of antibacterial and grab some graph paper. With some student help, I realized I have to cut 22 and 34 because they have inequalities with absolute value, and we did not do those yet. That will be in 2-8 day 2. So everything else should be good. The rest of this, if you see absolute value, it's okay. It's equalities, not inequalities. So just cut 22 and 34 and you'll be fine.